Hi, everyone. This is G. Shanmuka, and today our topic is understanding and fixing complex faults. Here, in the process of understanding and fixing these complex faults, there are multiple steps we involved in it, like configuration level, cognition level, cyber level, to information diversion level, connection level. These are the major levels that we put around for understanding and fixing the complex faults. Embedded systems are becoming more complex, and with complexity, faults are also a common issue. Let's explore now how to diagnose and fix these faults. Okay. Introduction to embedded cyber physical and physical systems. Okay. Here, embedded physical systems are the physical components of an embedded system that we use for fixing the complex faults. Microcontrollers, sensors, and cloud computing. Microcontrollers are embedded cyber physical systems are comprised of microcontrollers that control hardware components. The major examples for these are Arduino, Raspberry Pi. These are the circuit boards which are used to control the small components, small electrical components using specific given code according to our requirement, and the sensors. They are integrated with various sensors to measure and wait a second, there's a problem. Sorry. Sensors. They are integrated with various sensors to measure and control the physical environment. Here, sensors are the case which we use uh, any purpose to read, to get the temperature or to capture any object that is moving from one place to another place using distance sensor or any temperature sensors. Like that, many sensors are there, and these sensors are operated by the microcontrollers. Example, Arduino and Raspberry Pi. These are majorly we use in electronics subject, okay? And cloud computing. Cyber physical systems can communicate with the cloud, analyze and cloud control data. Here, to handle and to control all these components, means microcontrollers, sensors, and electrical gadgets or devices, we need a controlling unit, and this can be achieved using cloud computing. We use cloud computing to send the instructions to the microcontrollers, and these microcontrollers will send the appropriate required instructions to the sensors and the gadgets or devices according to our requirements by using the readings of the sensors. Okay. Here, understanding the complex faults in embedded systems. Okay. What are the complex faults? First thing, complex faults are hard to diagnose problems in embedded systems that arise from the interactions of multiple software and hardware components. Here, in this case of embedded systems, the complex faults can be of two kinds. First thing is software problem and hardware problem. Here in this software problem, there is a case of getting an error with the fault in software that we have given to the components, and here in hardware there is a chance of getting the problem or error with the hardware components, like there is any problem with the functionality of any device that could give some wrong report to the other device, and it could not work properly as required. Types of complex faults. Some common types of complex faults include concurrency, timing, and synchronization errors. These are the major types of the complex faults. Now, effects of complex faults. Complex faults can lead to unpredictable or incorrect system function, affecting system reliability and security. At last, overall, it cannot give the required output for the user what he is expecting from a complex system. Okay. Sources of embedded systems faults. Hardware faults, software faults, and environment faults. Yeah, I just missed that. Even the environmental faults can also be included for monitoring embedded systems. Hardware faults are hardware failures such as power supply issues, signal noise, and compute component aging can cause faults. Software faults. Embedded systems fault. Embedded software faults can arise from programming errors, incorrect system design, and interoperability issues. Environmental faults. Natural environmental factors like temperature, humidity, or electromagnetic interference could cause system faults. Challenges with fixing complex faults. Here, we don't only get by using the complex, we don't only get the challenges for by using complex faults, but also there are the challenges for fixing the complex fault. First thing is debugging complex faults and testing complex faults. Debugging complex faults is time consuming and often requires advanced technical skills and knowledge. Test complex faults. Test complex faults could be difficult since the fault could surface under specific operational conditions. Strategies for diagnosing complex faults. Model-based diagnosis. Model-based diagnosis includes creating a model of system and using it to identify the faulty components. Data-driven diagnosis. Data-driven diagnosis utilizes machine learning algorithms to automatically find correlations between data and faults. Hybrid approaches. Hybrid approaches combine model-based and data-driven technologies to achieve better accuracy and flexibility. Tools and techniques for fixing the complex faults. Debugging tools such as debuggers and code analyzers can help identify and fix the complex faults. Test automation. Test automation tools execute tests automatically, reducing and human error, speeding up the testing process. Fault prediction. Fault prediction tools use machine learning and statistical models to predict faults before they happen. Conclusion and takeaways. Complex faults are common. Complex faults are common in embedded cyber physical systems. Hardware, software, and environmental factors contribute to them. Diagnosing complex faults, model-based and data-driven and hybrid approaches are useful for diagnosing the complex faults, fixing complex faults, debugging tools, test automation, and fault prediction are the effective techniques for fixing complex faults. Now, this is the end of today's topic. I think you people got the brief idea about what is complex faults and understanding complex faults and how to fix these complex faults. Here, the major case to understand is majorly these complex faults can be get arised in the case of automation. In the case of automation, because if we use automatic door, which uses distance sensors, Arduino, and the device device in the sense the motor that we use to open and close the door. Here, there is a chance of getting any problem with the sensor. If the sensor doesn't work properly, the functioning of the door may not be worked properly. So there can be the chance of getting an error or fault in embedded system. The system itself is called embedded system, and even if the motor that we use to open or close the uh, door doesn't work properly, then there is a chance of getting an error because even though the sensor reads the data and sends the data or signal to the Arduino, and the Arduino gets the information and instructs the motor to either open or the door to close. The motor, as the motor is defective, the final output that user requires cannot be reached. This is the case. Like that, there are many cases where the complex faults are arised, and also many cases or solutions are there to fix the problem. This is the end of today's topic. Thank you guys.